Welcome. What I'd like to do is show you how to graph the ellipse. To graph the ellipse, though, before we do that, we got to make sure we have it in our standard form. And this is not in our standard form. And the reason why we want to have it in our standard form because then we can quickly identify what the center is, as well as what the vertices, foci, and co-vertices. So to put this in a standard form, the first thing I'm going to want to do is group the x and the y's and get my constant over to the other side. So I'll just rearrange this equation as x squared plus 10x plus 4y squared, 4y squared minus 8y equals negative 13. Okay, so I subtracted 13 on both sides. Now what I need to do to put in our standard form, I need to have that binomial squared, right? That's what tells us where our center is going to be. So I'm going to use parentheses around my x's and around my y's. And what I'm going to do is I now need to create, out of these two binomials, I need to create a binomial squared. So to do that, I have to complete the square. So let's look at the x's first. Now again, remember to complete the square, you're simply going to take b divided by 2 and square it. And where b comes from is ax squared plus bx plus c, which is the standard form of a quadratic. Well, here we only have an a and a b. A is 1, b is 10. So I'm just going to take 10 divided by 2 and square it. Now, this equation, we got to make sure whenever we're completing the square that we factor out an a. And actually, let me rewrite this one more time. So therefore, I have, all right, so we have 10 divided by 2 squared, right? 10 divided by 2 is 5. 5 squared equals 25. OK, so I have x squared plus 10x plus 25. So I'm going to add 25 inside of this parenthesis. Plus, now here, to factor this out, I got to factor out the 4. So I factor out a 4. So I have y squared minus 2y equals negative 13. Now, since I added 25 inside this parenthesis, I need to add 25 over here. So I add 25 over there. Now, let's complete the square for this one. So I'm just going to simply take negative 2 divided by 2 and square it. And that equals positive 1. Now, let's go and add that inside that equation. So I have x squared plus 10x plus 25 equals 4 times y squared minus 2y plus 1 equals negative 13 plus 25 is going to be a positive 12. OK, so since I added 1 over inside this parenthesis, I need to add the 1 over here, right? But remember, this 1 is being multiplied by 4. So therefore, this 1 also needs to be multiplied by 4. Therefore, that's 4 times 1 plus 12 is going to be 16. Now, over here, the whole purpose of why we did this, why did we complete the square to make these perfect square trinomials? Because each one of these can now be factored as a binomial squared, which is x plus 5 squared plus 4 times y minus 1 squared equals 16. And we're almost at our standard form. But before we get to our standard form, we got to make sure we set it equal to 1. So I divide by 16 on both sides. Now the 16 divides in. That goes and simplifies to 4 over here. And then it just divides in. Remember, the 16, you have to divide it into both of these terms. So therefore, I have a final equation of x plus 5 squared over 16 plus y minus 1 squared over 4 equals 1. OK, so now I've found the standard form. Now the next thing I need to do is I need to graph this. And to graph this, I need to be able to determine, well, is my horizontal axis, or is my major axis horizontal, or is it vertical? And you can see in this case that my major axis is going to be horizontal, since the larger number is under the x, which is our a squared. And you can see the general form of that equation right up here. X minus h squared plus y minus k squared equals 1 all over a squared over b squared. Now remember, a represents the distance from the center to the vertice, which is always going to be larger than what b represents, which is the distance from the center to the co-vertices. So that's why, since 16 is larger than 4, I know that this is going to represent a squared, and this represents b squared. And since a squared is under the x, I know my major axis is going to be horizontal. So when we go to graph this, first thing we want to do is identify what the center is. So you can see our center here. Remember, it's opposite of h, opposite of k. So my center, which is h comma k, in this case, we have negative 5, positive 1. So now I'm going to plot that point, negative 5, 1, 2, 3, 4, 5, positive 1. And then I just go ahead and simply label that as my center. Now the next thing is, remember, we determined that we have a horizontal major axis, right? And the horizontal major axis, remember, is the distance where my center, my vertices, and my foci all lie. So the next thing I want to do is identify what a is going to be. So I know that a squared equals 16. So therefore, a equals 4 when I take the square root of both sides. Therefore, from the center, I need to go 4 units to the right, 1, 2, 3, 4, and 4 units to the left, 1, 2, 3, 4. And those are my two vertices. All right, so I can say vertices. And the vertices are now going to be at the point. Now remember, they're going to have the same y coordinate as the center, but now they're going to be at negative 5 minus 4, which would be negative 9, comma 1. And then negative 5 plus 4, which would be at negative 1, comma 1. The next thing is we need to determine what is our co-vertices. And our distance of our co-vertices is 4. So we know that b squared equals 4. So therefore, taking the square root of both sides, you can say b is equal to 2. Now, unlike the vertices, or similar to the vertices, we're just going to add that to our center. But unlike our vertices, they do not lie on the major axis, but rather they lie on the minor axis, which is perpendicular. So since b is 2, this is up 1, so I'm going to go 2 units above and 2 units below. And that's my co-vertice and co-vertice. So we can say my co-vertices. And now to find these points, I'm just going to add 2 to the center and then subtract 2. So the x-coordinate is going to be the same, right? There you can see they have the same x-coordinate. So my co-vertices are going to be negative 5, negative 1, and negative 5, comma 3. All right. I'm going to erase some of this to go over to the foci. So the last thing we need to do is identify the foci. And the distance from the center to the foci is c. So the problem is we don't know what c is, right? However, we do have a relationship that says c squared equals a squared minus b squared. So now plugging that in, I can say c squared equals 16 minus 4. C squared equals 12. Take the square root of both sides. C equals the square root of 12, which I can simplify that into 2 square root of 3. Now, I could use the decimal approximation for that. Square root of 12, that's going to be anywhere between 3 and 4. So it's going to be 3 and a decimal. And that will help me when I'm plotting them. I can go over 1, 2, 3. And it's going to be some decimal in between 3 and 4. To the left, 3, 1, 2, 3, and some decimal right in there. You could get exact with the calculator, but that's not my major focus. The major focus is understanding where the foci, vertices, center, co-vertices all lie and kind of estimating their points. However, we still want to write in what are the points of the foci. So to keep those points exact, I'm not going to use a decimal approximation. The one thing important, though, since I know that the foci lies on the major axis with the center and the vertices, I know that the y-coordinate is not going to change. So therefore, my foci is going to be negative 5 minus 2 square root of 3, comma 1, and negative 5 plus 2 square root of 3, comma 1. So there you go, ladies and gentlemen. That is how you graph an ellipse, as well as identify the center, the vertices, co-vertices, and foci. Thanks.